to get as deep as you need in this. Before we get to the internet, to make things easier for you guys to understand, we'll start by talking about the traditional mail system. How does the traditional mail system, when you are sending a package or you're sending a letter, which no one does right now, but let's assume we are, when you are sending a letter to a friend in a different state, let's say we are in California, we are sending a letter to someone in New York City, what happens starting from you writing the letter until your friend in New York City reads the letter? Yes, Finn.
So you make sure to write their address and your return address. You bring it into either a PO box or mail drop off, and from there it gets collected into your local city, and then from the city it gets shipped to a local hub, and from there it bounces around to other hubs until it gets to the final hub, which then it will get delivered through mail truck to your person's address.
Perfect. That's perfect. So that's right, but let's get into a little bit even more details. So the first thing is you are going to start writing your letter, whatever you will put there, right? And then you are going to, after you write your letter, you are going to put it in an envelope, make sure you write the correct address and the stamp, right? And then it's going to be forwarded, as Sheen said, to the local exchange or local mail center, to be collected there, right? So we're going to put address, okay? And then your local mail center will look at what? They will look at the postal code, right? They will look at the postal code on your envelope and then or your package, and then based on this, so this will examine the postal code, right? And based on that, they are going to forward this postal code into, let's say, a global hub. Okay. Right. And then let's say this global hub is in, we are writing the letter, we are in Seaside. Right. This global hub, let's say it is in San Francisco, for example. Okay. And then again, this global hub will examine your, now there are multiple global hubs. There is one global hub in San Francisco, another in Los Angeles, a third one in Las Vegas, for example. And based on the postal code, your local mail center will decide that the closest global hub to New York is the San Francisco one. So they are going to forward the mail to San Francisco. And then San Francisco again will examine the postal code. And based on the value of the postal code, they are going to forward it to several hubs. So the letter doesn't go straight to New York from San Francisco. It passes through Nevada to Chicago to maybe a third city until it reaches the end city, which is New York City. So we'll put it as a cloud here. Okay, so we usually put it like this. Okay. It's the cloud. So there are multiple hubs here which are going to receive your mail, okay, until it reaches New York City. Okay, right. And now New York City will look at the address that you have on your letter, and will send it to the correct, your friend who will open it and read it, right? Right. And this is your friend who is going to open and read the letter. Does everyone agree on that? Any comments on that? Anything that should add or remove? Okay. So Now we are going to take this and map it to the internet, because the internet works exactly in the same way, but everything is automated, more automated than this, but it works exactly in the same way. So let's now move to the internet and look at how the internet will manage this thing. Okay, so I'm going to open a new browser or new whiteboard, and let's look at the internet, right? So we'll start by you writing an email. Okay. Okay, so you are going to write an email, and you are going to write the address to, for example, to me. Okay, and some content here, right? And then you are going to forward it to your local hub. Okay, this is your local hub. Before we go any further, when you are writing your email, you are writing your email either by opening the browser and going to Gmail or whatever email you are using, or by using Outlook or any email client on your computer, right? So there is an application here, right? You are using an application. This application can be the Outlook if you are using Outlook, or it can be by opening a browser window and going to your email website and then entering this email, right? And the local hub is the server that is hosting your email. So this is a server hosting your email. Okay. Okay. Now the server is supposed to get your email to a global hub, right? It needs to go to a global hub like the email. Right. So the question now, guys, is when we were looking at the yes, Brenda, that could be the Google. Let me put that here. That's a good point. Let me add this. Yes, so this can be the Google Gmail servers. Okay, this can be Hotmail servers, any server depending on the email you are using, right? That's a good point. Thank you so much. Right, right. So now we want to go to a global hub. If you go back to the previous page, in order to go to the global hub, the local mail server or the local mail center in this case had to look at the postal code to determine which global hub will the mail be forwarded to. So the question that we have here, guys, which is interesting, is how does your local hub or your local server know where to forward your email, where to send your email? How does it know this? Yes, Shin.
Just like in the mail, it has a certain address. I'm guessing some sort of binary code. It could also be in the search bar, like the HTTP://.
Okay, so you are on the right, you are in the right track, but this is not 100% correct. So you are right, but how does the server gets this code? What this number, this binary code you are talking about? How does the local server get it? There is no information in the email about this code. We only have the content of the email and the address of the one who will be receiving the email. So where would this code come from? So you are right, but 50-50, right? So in order for the local hub to forward, okay, so the domain name, what? Okay, so you are again 90% right. Okay, so in order for the local hub to forward the mail to the right global hub or to the right address, it needs to translate the URL or the address. Your address has URL at the end at csumb.edu. It has to translate this address. No, not MAC address, Nicholas. MAC address is completely different. But this is a good question. Please keep this question in mind because we'll come back to it again. So please keep it in mind. Okay. Right. So when you are sending out an email or writing a web address on the web browser www.csumb.edu, there is an address part, csumb.edu, right? But this is not a code. This is not an address. This is the name of the server or the name of the website you want to go to. This is the name of the location your friend is using for their email, right? This is not an address. Okay. We need a way. We need a technical method to convert this name, this what we call a domain name. It's called domain name. It's a name for your company. So we call it domain name. We need to convert this domain name into an address. So how do we do this on the internet? On the internet, there is one central device on the internet, one central component of the internet that without it, there is no internet. Okay, so the component I will talk about now is the internet. Without it, there is no internet. DNS, yes, Matty, absolutely right. Right? So we have something here. We'll talk about in details about this DNS later on, but I will explain its role first, and then we will talk about how it works. But first, I will explain the role of the DNS. Okay. Okay. And I want to change its color to something. Okay. Okay. This is a service called domain name server or DNS. Okay. What does this domain name server? Simply put, this domain name server contains a list of all the names of the domains in the world. So for example, it has csumb.edu, right? And in front of it, it has the address of this server. So it has the address we have on the internet. We are using an address called the IP address. IP address consists of 4 parts with dots between them. So something like this: .212.111.213. Okay. Okay. So this is the format of the IP address. It has 4 components, each one from 3 numbers with dots between them, and these numbers must be less than 256. Okay, so this is too technical, so I won't tell you why they should be less than 256, but you trust me with that. It's 4 numbers separated by dots, each one 3 digits, and these digits must be less than each number must be less than 256, right? So when your local hub gets your email, it contacts the domain server. So it's going to contact the domain server saying what is the address for csumb.edu, and your server will reply saying this is the IP. It will reply with this address. So your local hub will ask the domain name server. No, not each device, Michael. It's specific to each domain, each company name. So csumb overall has one address, which is this address. Okay, that's a good question, though.
No, I meant like my address. It's linked to my device, not to my server, right? Is that the right question?
Yes. So I will reach this in a minute. When we get to the final destination, I will say how it's working. Okay. Right. So this is the web address or the internet address for csumb overall. Anyone using the csumb server shares this address. Okay. Anyone in csumb server shares this address. Okay. So the role of the DNS is central in the internet. Okay. Because when you write an address on any web browser, you write it like this: csumb.edu, cnn.com, netflix.com, and so on. And therefore, this address needs to be translated into an IP address like here in order to be used by the hubs on the internet. Okay. So your local hub will send a query to the DNS asking for the address corresponding to csumb.edu, and your DNS will respond saying that the address is 110.212.111.213. Okay. After this, based on this address, okay, your hub is going to select the global hub to forward this email to. So your email will be forwarded to the global hub. And then again, the global hub will look at your IP address. So the global hub now has this address sent to them. So they will examine. Isaac, you are using my screen, so please don't. Okay. Examine the IP address. Right. And based on that, after examining the IP address, they again will forward it through different hubs. So again, there will be different stuff here, different things here, different hubs that in the middle. Okay. And then after going to the different hubs, let me see if I can expect this a little bit. Okay. Okay. It is going to be forwarded to the final destination, which is csumb.edu. Okay. So the goal of the domain name server, which is central in the without the DNS, there is no internet. Okay. This is why sometimes, guys, when the internet breaks down, you try to type any address in the internet and you cannot reach your destination because someone attacked the DNS server. So if these DNS servers are down, you cannot access the websites listed in this server. Okay. So this is why it's key. Domain name server is key. Right. And now we reach the CSUMB and this is our destination. Right. Now there is a problem here, guys. This is how the internet works in general. You write the email and this is how it gets to the csumb.edu. The problem here is, okay, so it's in the csumb now, but how does it get to my computer, right? This IP address is related to csumb. It's not my computer. It's not the computer I'm using right now. So how does it reach my computer? Let's open a new screen and see. Okay, so now we reached that we are in csumb now. Okay, so this is the CSUMB mail server, right? Once it gets to the server, the CSUMB server, then we look at the first part of the mail address. It's Abu Zahra, right? Abu Zahra, right? So by looking at the first name, the server, my name is in my local server. So my name is registered in the CSUMB server, right? So the server knows my machine. It knows my mail client, and it was going to forward this mail automatically to my client. So it's going to come to my client based on this name here. Okay. Now, the IP address. Let's talk about. First of all, let's go back here, and I want to, if anyone has any questions or anything they want to clarify. Yes, Shin.
I was wondering, so after the after it goes to the global hub, what is the arrow down and the little squiggly cloud? Is that just the cloud base? Is that what that's supposed to represent?
Right. So I will show that to you. Let me show that to you in practice. So let me show that to you. CMD. Right. I will show you a command that we use in the command prompt that traces the hubs that we go to until we reach a certain server. So we are in CSUMB, so I want to use CSUMB. We have a command called ping, not ping, trace route, trace RT. Trace route will trace the links until we get to whatever server we want. Okay, so I will trace route cnn.com, for example. Okay, now look what's going to happen. Okay, so first of all, CNN.com, the 151.101.65.67, this is the IP address of CNN. So the DNS replied to me saying CNN corresponds to this web address 151.101.65.67. Okay, and then in order for me to reach CNN, these are the servers I will go to until I reach CNN. Okay, so I went to one hub called 192.168.86.1, then another one called 10.10.8.1, and then 198, and then until you reach your destination, right? So you don't just go to your global hub to go to CNN. You go to multiple hubs, you go to multiple servers. So this cloud that you see in front of you here represents the other hubs. I cannot tell you 5 hubs, 6 hubs. I'm not sure about that. So this cloud is to represent any number of hubs or any numbers of servers we'll go through until we get to our destination. Okay. Yeah, you can say it's based on this, yes.
I had never even thought about that, but yeah, it's like they took they applied the mail concept to the phone lines, and I don't know, because it seems like the IP address is basically just what a phone number, and like the coming into the server is an area code, and then your IP address is like your local phone number almost.
So I have so many good questions here. I want to answer them all. So let me answer. I have Brenda's question saying, where are CSUMB servers located? Are they on campus? I think of data center, so I'm not sure if this is correct. There is a server room on the server. Do you know where they are located on campus? Okay. So let me answer Brenda because she has a very good question. Right. So Brenda, the server can be located on campus. Okay, it can be located on campus, and 100% CSUMB has a server room in the IT department. If you go visit the IT department, you will see that they have a room that is specially protected by some security that is cooled, and it contains the local servers that we use at CSUMB. But the servers do not need to be hosted at CSUMB. For example, our mail servers, the mail servers at CSUMB, they are hosted on Google site. Okay, it doesn't matter. Okay, this is not physical. This is logical. So this server can be anywhere. The CSUMB server can be hosted in CSUMB. It can be hosted on Amazon Web Services, cloud service. It can be hosted anywhere, regardless. My name as a user of this server, my name is registered. My name is stored on this server, regardless of where this server is. Okay. Yes, Shin.
So if it doesn't matter where the server is, why do we have our servers on campus? Like, why don't we just put it in?
We don't, not all our servers are on campus. Okay. This is what cloud computing is about. This is what I will talk about next week. Okay. This is what cloud computing is about. So a server can be hosted somewhere else, but my data, the local data is on this server. So I can send all my users' names, I can send them to the server wherever this server is. So we do have some servers here, but not all the servers.
Okay, for sure.
Yes, all servers need to be in cool environment because they dissipate lots of energy. Yes. Right. So anyway, this is after it gets to csumb.edu. Again, whether this server is hosted on csumb.edu campus or outside, then we start the second phase. CSUMB will say, okay, Emma Buzahra is one of my users, so I am going to send this email to his Outlook or to his inbox. Okay, right. So now this is how the internet works in general. What I'm going to say now is a little bit more technical. So if it confuses you, drop it. Okay, so what I'm going to talk about now is a little bit more complicated. So if it confuses you, drop it. Okay, right. So we talked about the IP address associated with whole csumb.edu. Okay, but if you're on campus or at home, you will find that each computer has its own IP address. Okay, each computer has its own IP address. So my IP address is, you can see it here. This is my IP address. It's not here, but this is okay. This is the IP address of my network, of my router, okay, that connects me to the internet. My IP is not here, but I can. What is it called? The command. I forgot the command, but you can see that each computer has its own IP. So how come each computer has its own local IP and the whole campus has one IP? So what is the relationship between these two IPs? I will tell you what. Okay, so the key thing here is, guys, there is a DNS domain name server global that connects, that has the IP addresses of the main servers online. Okay, once we get to the local server, once we get to our local domain, CSUMB domain, then we have here local DNS. Local DNS. This local DNS only has addresses of computers on campus. Okay. So let's say, for example, one of the departments is the IT department. Okay, so the IT department would have an address like this, it.csumb.edu, for example, okay, or something like College of Business. It would be something like cob.csumb.edu, right? So once the email, or once you try to access the a local address inside CSUMB, there is a local DNS here, right? So once your request comes to the server of CSUMB, what happens is the CSUMB server will contact the local DNS, okay, and will get response of the COB email IP address, and it will forward your request to College of Business. Okay, so there are multiple levels of DNS servers. There are local DNS servers and there are global DNS servers. Okay, any questions about that? Okay, right, so I'm going to stop here now, but next time I'm going to build on that. So next time we are going to dig deeper into the DNS. We will understand the hierarchy of the DNS. What is the relationship between local DNS and global DNS? Why do we have this csumb.edu versus cnn.com? What this .edu means and what this .com means? And we will learn more about how servers communicate with each other, because CSUMB server may be running on Windows. The Gmail server may be running on Linux, different operating system. So how do they communicate with each other? How do they talk to each other, saying that this is an email for Mohammed, we received your email? How does this happen? Okay, we'll learn about this next Wednesday. Okay, so I will stop here.